This problem is a lot more like what you'd be likely to see on the AP test. So I have a function here. It's the rate at which somebody burns calories while they're on an exercise machine. And this first piece, the piece that goes from 0 to 4, we've been told that's polynomial. We've actually been given a function for that piece. And the 1, 2, 3, 4 other pieces of this piecewise function, they look linear, and the problem tells us that they are in fact linear. So check out this question. For the time interval that's given, 0 to 24, at what time is f increasing at its greatest rate? So there's a lot of words there that can be confusing, so we want to recognize this as an optimization problem. Remember our 7 steps and see what we can do here. So at what time is f increasing at its greatest rate? What is it, what quantity is it that I'm trying to optimize? And this time, and I know greatest means I'm trying to maximize something. So I want to maximize the function that tells me how f is increasing. Well, the function that tells me about the rate at which f is increasing is f prime. So I say that this here is a scenario where we want to maximize f prime of x. Okay, so now I know what function I want to optimize. I need a formula for that function, and I'm going to find critical points for that function. So I need a formula for f prime. Here's the funny thing. Okay, so f prime is f is piecewise, which means f prime is also going to be piecewise. I can find, it's like I'm going to have to find a bunch of little derivatives. So I know f prime on 0 to 4 is going to be the derivative of this polynomial function. So that's going to be negative 3/4 t squared plus 3t. I know f prime here is 0. I know f prime here, I'm going to have to do change in y over change in x to find the slope of f on this interval to find f prime. So there's going to be a second interval, or f is 15 minus 9 is 6 over 16 minus 12 is 4. So I'm going to say f prime of, I'll just label it f prime of 14 is 3 over 2. And that's the same as f prime of 12.1 and f prime of 15.9. Here, this next piece, f prime is 0 again. And here, notice f is decreasing. F prime is going to be negative. So I'm just going to leave that one out because I'm supposed to report when f is increasing at its greatest rate. The only possibilities are going to be on intervals where f is increasing. So I'm going to skip that part where I find the derivative on the interval 20 to 24 because I know f isn't increasing there. So let's see what I've got. So I'm trying to maximize f prime, which means I need critical points for f prime. So critical points for f prime are going to come from where f double prime equals 0 or where f double prime is undefined. So I'll start by finding f double prime of 0 for this interval 0 to 4, which is the only place where I actually have an interesting function for finding f double prime. So f double prime of t, that looks like negative 3/2 t plus 3. I'm interested to know where that function is equal to 0. So I'm going to, woo, what happened there? Let me try that again. I'm taking the derivative of negative 3/4 t squared plus 3t. That's going to be negative 3/2 t plus 3. I need to know where f double prime equals 0. That's going to be negative 3/2 t plus 3. So I'm going to get 3/2 t equals 3, which means t is 2. All right, so what do I have? I have critical points for, well, I have one critical point for f prime, which is a place where f double prime equals 0, which is at time equals 2. So I'm going to put together my list, my table of values. All right, so what numbers are going in my table of values? I could add endpoints. So I could think about all these different endpoints. But the problem is, I'm trying to maximize f prime, so like it's only going to be helpful to find places where f prime is actually defined. So I can think about these endpoints, but notice here, and here, and here, and here, and here, f prime is undefined at all those places. So think about what I'm going to add to my table. I have one critical point for sure, which happens when f double prime was 0, which was at t equals 2. And then think about the places where the other places where f double prime is 0. So here, f prime is 0, so f double prime is also 0. Here, f prime is, we said, 3/2, so f double prime, so the derivative of a constant, is also 0. Here, 0. So I'm going to have to put in a place to test f prime. I know that it's probably not going to be these places because f is not increasing, and I'm looking for a place where f is increasing. So I'm going to add to my table something like, I'm going to make up a notation here, something to indicate that I'm interested to know about the behavior, about the value of f prime when t is somewhere between 12 and 16. Okay, so now I'm going to plug these interesting values into my function that I'm trying to maximize, which is f prime. I'm going to pick the biggest one out of the table. So I know f prime on this interval is the slope of that line. I figured that out before. That's 3/2. The other critical point I have to test is when time equals 2. So I'm going to have, oops, I erased my f prime. F prime of t is negative 3/4 t squared plus 3t. So f prime of 2 is negative 3/4 times 4 plus 3 times 2 is 6. That's negative 3 plus 6, which makes 3. So I'm going to conclude that f is increasing at its greatest rate when time t equals 2, because at time t equals 2, f prime of t is greater than f prime evaluated at any other time along the function. So I'm going to write that up. I'll use the typewriter function to write it up and show you what you would say. So here's my final write-up. F of t is increasing at its greatest rate at time t equals 2 because f prime of 2 is equal to 3, which is greater than f prime of t on any other interval, specifically that interval that I had to test, which was the interval from 12 to 16.